So in this video, we're going to apply the chain rule in a case where we also need to involve the product rule. And then we're kind of scaffolding things, so I don't have the little cheater box with the rules in it here on this slide. So now I'm going to start doing it from memory. So it says find d dt of f of t, or in other words, find f prime of t, find the derivative of f of t, for f of t equals 3 times t to the fourth times t cubed minus 2t squared minus 2 all cubed. So I'm going to go ahead and rewrite the original problem. So 3t to the fourth times t cubed minus 2t squared minus 2. And what you can see, there's a bunch of things going on here. I have a constant multiple, so I have a derivative involving a constant multiple. I'm going to have a derivative involving a product. I'm going to have the function t to the fourth times this function cubed. So there's a product rule going on there. There's a chain rule going on because I have a function composition. I have this cubic polynomial inside of a cubing function. So I've got multiple things going on. So when I go to calculate the derivative, f prime of t, the first thing I want to recognize is that the derivative of a constant multiple of a function is the constant multiple times the derivative. So when I take the derivative of this, the 3, the constant multiple, is just going to be sitting out by himself. I don't need to involve him in taking the derivative. 3 times the derivative of this stuff right here is what I'm going to get. And then I want to recognize that I need the product rule. I need the derivative. So the product rule says take the derivative of the first function times the second function. That's how the product rule starts. So I'll see the product of two functions that I've underlined here. So a constant multiple of the derivative of that product is going to start off using the product rule. Product rule says take the derivative of the first function. So the derivative of t to the fourth, that's a power rule. So the 4 will come down into the coefficient position on the t, and then we'll get t to the reduce the exponent by 1. So take the derivative of the first function times the second function. The second function is t cubed minus 2t squared minus 2 all cubed. Plus, I'm using the product rule, so now it's plus. And then the product rule says take the first function, which is my t to the fourth, and multiply that by the derivative of the second function. So I need to focus in on the second function right now, which is this guy right here, t cubed minus 2t squared minus 2 all cubed. This is a chain rule because the outer function is the cubing function and the inner function is that third degree polynomial, t cubed minus 2t squared minus 2. So now I have to think about the chain rule. And the chain rule says take the derivative of the outer function. So the derivative of the outer function is the cubing function. So to take the derivative of the cubing function, I'm going to bring the 3 down into the coefficient position and then reduce the exponent by 1. So I'm going to get 3 times stuff squared. And then the chain rule says take the derivative of the outer function at the inner function. So inside of here, we get the t cubed minus 2t squared minus 2. So remember, the chain rule says to take the derivative, if you have a composed function, d dx of f of g, that you're supposed to do the derivative of the outer function at the inner function, which is what I just did here. The outer function was the cubing function, and then multiply the result by the derivative of the inner function. So now I look at the inner function, and I'm going to multiply by its derivative. So times t cubed by the general power rule is just 3t squared minus 2 times the derivative of t squared. So the derivative of t squared is going to be 2t. So I'm going to get minus 2 times 2t is going to be minus 4t. And then the derivative minus the derivative of a constant, but the derivative of a constant is 0. So I'm going to be subtracting 0. So we don't need to worry about that. And then what you want to do, because we used the product rule and we have a sum of terms, we want to look and see if anything can be factored. So when I look at the interior terms, I see that I have a t cubed and a t to the fourth showing up in each of the two terms. So a t cubed can be factored out. And then I have t cubed minus 2t squared minus 2 here showing up cubed, and here showing up to the second power. So I can factor out a second power of t cubed minus 2t squared minus 2. So I'm going to factor out a t cubed, and I'm going to factor out a t cubed minus 2t squared minus 2 squared. I'm going with the smaller exponent. This says I have 3 copies of that third degree polynomial, and this says I have 2 copies of that third degree polynomial. So I can factor out 2 copies. So t cubed minus 2t squared minus 2, factoring out 2 copies of it, times now what gets left behind. So I didn't factor the 4 out, so the 4 is left behind. I factored out a t cubed, so there's no t cubed left in here, and I factored out 2 copies of the third degree polynomial. Because I factored out 2 copies, it's going to leave behind 1 copy because I started with 3. So it's going to be 4 times t cubed minus 2t squared minus 2 right there, and then plus, I didn't factor out a 3, so the 3 is still going to be there. I factored out, that was a t to the 4th. I think I got it with my eraser. So I factored out 3 copies of the t. So here there were 4 copies of the t. So t to the 4th, I'm factoring 3 of them out, which leaves 1 behind. So a 3 and 1 of the 4 t's is left behind. I factored out 2 copies of the third degree polynomial, so I'll have none of those left behind. But this guy didn't get factored out, so he'll be left behind. So I have left behind a 3t squared minus 4t. And close off this parentheses over here. So maybe I'll even make this a square bracket. And now I want to do some simplifying on the square brackets right here. Square bracket pairing with the square bracket right there. This goes with this guy right here. And now I'm going to need to do some simplifying on the inside of this parenthesis. So I'm going to go ahead and go down to the next line, rewrite the 3t cubed times t cubed minus 2t squared minus 2 times, I'm going to distribute the 4 into the parentheses. I get 4t cubed minus 8t squared minus 8 plus 3t times 3t squared is 9t cubed plus 3t times minus 4t is going to be minus 12t squared. And now I'm going to go ahead and combine like terms inside of there, equals 3t cubed times t cubed minus 2t squared minus 2 times 4t cubed plus 9t cubed is 13t cubed, combining like terms, minus 8t squared minus 12t squared is minus 20t squared, and the constant term minus 8. And now eyeballing these, this doesn't look like, I lost something there, didn't I? Right there, there was 2 copies, there's 2 copies, there's 2 copies. I lost the squaring. And then I want to look at this, and it doesn't look like anything is going to factor easily right here, so I'm going to go ahead and leave it. I think at this point, things are about as simplified as we can get them. So the idea is if you can make basic algebraic moves to do simplification and they aren't onerous, then you need to do them to do the simplification. In this case, identifying that there were common factors that could be factored out is in my opinion a simple simplification process, and so it does need to be done. And then once you get it to this position, these multiplications, the multiplication by 4 and the multiplication by 3t, were also simple to do, and combining like terms is a simple simplification process. So those are all things that I would expect to be done on an exam. Once you get it to here, there isn't an obvious factorization for this, and this is already factored. We don't want to multiply this, we don't want to square this out and get a bunch of terms. So it's, a factored form is going to be the most ideal form to have this in.